All right, I'm going to be going over how to solve exponential equations using logarithms, and specifically with word problems. So this is actually a really important video because this is summing up everything that we're learning, and you know how my tests are. There are a lot of word problems, so we can't avoid them. Now I'm going to do this on a warm-up page. If you don't have any space on a warm-up page, then you can either find another space in the packet, or I'd staple a loose leaf sheet of paper to the packet because I need to see these notes here when I collect your packet. So I'm just going to use the lower half of this warm-up page, and I'm going to divide it into half, or actually, sorry, like a quarter, because there's two problems. So there's example 1 and example 2. So the first example that I'm going to go over is, let's go to it here. All right, number 1. The interest equation A is equal to P times e to the RT can be used to determine the final value A of a continuously compounded interest-bearing account for T years after initial amount of money P was deposited. So you guys, all those finance majors, this is going to be really important for you. If $830 is the initial deposit and the account earns 2.3% interest, which expression can be used to determine the number of years required for the value of the account to triple? Okay, I'm not going to require you to write this all down. However, I want us to write down specifics. So the first thing I want to write down is the equation. A equals P e to the RT. All right, after we have that equation, now I'm going to write down other important information. So $830 is the initial deposit. So I'm going to make a bullet point. Initial is equal to $830. What other key information do we have here? The account earns 2.3% interest. So if I'm earning it, that means I'm adding 2.3% to my account. That's going to be my growth rate. Which expression can be used to determine the number of years? So I'm solving for the number of years. That's what I'm solving for. I'm going to be solving for T. Required for the value of the account to triple. The value of the account to triple. See, this is a piece of information. However, I need to do a step to actually figure out what the value of the account is when it triples. If I start with 830, that means to triple the account, I'm going to have 830 multiplied by 3. So let's find out what that is. So I want to get to 830 times 3 to triple, 9. So I want to get to 2,490. That's the amount of money. So these are like my 3 main bullet points here. So let's see where I can plug this into my equation. Now E, that's its own variable. Remember E, just like pi has the 3.14 estimation, E has the estimation 2.72. P here, that's our initial value. So this equation looks a little bit different than we're used to, but it's the same types of things that we're dealing with. A is what's on the left side of my equation, what Y is. So A is going to be 2,490 because I want to triple my account, triple the amount I started with. P is the amount I started with, which was 830. E is the estimation there. R is rate. Now, if R is rate, 2.3%, I want that in a decimal. So I move my decimal place over 1, 2. So this is equal to 0.023 as a decimal. So my rate here is going to be 0.023 times whatever T value. I don't know T. That's what I'm solving for. So I should have plugged in every single thing except T, which makes sense because that's my variable. All right. So now I want to solve for T. Now, the first thing that I can do is I can get rid of this 830 by dividing it. So divide 830.
Dan Yadego to the front office, please. Dan Yadego, front office.
So 2,490 divided by 830. Online calculator. Alright, 2,490 divided by 830 gives me 3. Well, that worked out lovely. So 3 is equal to e to the 0.023 to the t. Now I'm stuck with my exponent. So how do I get this t alone? Well, if I don't want it in an exponent, then the inverse operation of exponentials is logarithms. So, but we have this e here. Remember, I'd usually take the log of both sides, but now that I have e, we take the natural log of both sides. Natural log ln instead of log log. Alright, so now I have the natural log of 3 is equal to the natural log of e to the 0.023 to the t. Now, if I want to keep going, the whole point of taking the log or the natural log of both sides is so this exponent comes down here. So this is going to be the natural log of 3 is equal to 0.023 to the t times the natural log of e. We remembered a key thing here. One thing that we needed to memorize was the natural log of e is equal to, did we forget? If we forgot, let me look at my online calculator. My natural log value is here, and my e value that you guys can't see very well. Okay, sorry. Alright, so the natural log of e is right here. Parentheses is equal to 1. Natural log of e is equal to 1. Let's do that one more time. The natural log of e, close my parenthesis, is equal to 1. Yay! So, if the natural log of e is equal to 1, that means this whole thing right here is equal to 1. So it's like 0.023 to the t times 1. So we don't even need that there. Natural log of 3. And then my last step, 0.023 times t. If I want,
snacks are getting served. Snacks are being served.
Oh, yikes. If I want t alone, I divide by 0.023. So t is equal to the natural log of 3 over 0.023. And if I actually want to find out that time, I can either leave it like this, or I can do the estimation in my calculator, natural log of 3. So clear this. The natural log of 3 divided by 0.023 is equal to 47.8. So that means it's going to take 47.8 years. Or you could have rounded that to 48 years. Doesn't matter. I would take both of these answers. Alright, cool. Let's do one more. Yay, fun. Alright, the population in a small town is experiencing an exponential population growth. Probably LA is too. Where PO is the initial value and P of T represents the population after T years. If the town's initial population is 1,265, which expression could be used to determine the number of years, so we're solving for T, number of years, until the population reaches 4,000. Alright, so let's do bullet points on what we have. We have an equation, so let's write that equation down. P of t is equal to POE 0.051. Right. So we have P of t is equal to POE to the 0.051 t. Okay. So now we have our initial population of the town is 1,265 people. No, please don't freeze. Alright, because this is frozen, I'm just going to cut it off here.